Numerical problems from surface tension. 1. What is the pressure inside a drop of a liquid of radius 3 mm at a room temperature? The surface tension of the liquid is given as 0.465 Newton per meter. So radius is 3 into 10 raised to minus 3 meter, surface tension 0.465 Newton per meter. We want to calculate the pressure inside the drop. We know the excess pressure is equal to pressure inside the drop minus atmospheric pressure. Therefore, pressure inside the drop is excess pressure plus atmospheric pressure. So that is 2T by R plus atmospheric pressure is 1.01 10 raised to 5. Substituting the values, we have 1.013 into 10 raised to 5 Pascal. In second problem, air is introduced through a nozzle into a tank of water to form a stream of bubbles. If the bubbles are intended to have a diameter of 2 mm, calculate how much the pressure of the air at the tip of the nozzle must exceed that of the surrounding water. Assume that the value of surface tension between air and water is 72.7 into 10 raised to minus 3 Newton per meter. So the diameter is 2 mm means radius is 1 into 10 raised to minus 3 meter. And surface tension is 72.7 into 10 raised to minus 3 Newton per meter. So excess pressure P is equal to T by R. That substituting we have 145.4 Newton per meter square. That means the pressure of the air at the tip of the nozzle must exceed the pressure of the surrounding water by 145.4 Newton per meter square. Here the excess pressure inside a soap bubble of radius 8 mm is balanced by a 2.5 mm column of oil of density 800 kg per meter cube. Determine the surface tension of the soap solution. So the bubble, the excess pressure of the bubble is balanced by a column of oil. So that the radius is given as 8 mm, that's 8 into 10 minus 3 meter. Height of the oil column is 2.5 into 10 minus 3 meter, and the density of the oil is 800 kg per meter cube. So we have the excess pressure inside the soap bubble is balanced by pressure exerted by oil column. That is 40 by R is equal to pressure exerted by the column is H rho G. From that T is equal to H rho G by 4. Substituting the value of H, rho, G and R. We have 3.92 into 10 raised to minus 2 Newton per meter. Here calculate the work done in blowing a soap bubble of radius 5 cm. Surface tension of soap bubble is 0.03 Newton per meter. So our radius is 5 into 10 raised to minus 2 meter. T is 0.03 Newton per meter. We have learned work done in blowing a bubble is 8 pi r square T. That is two surfaces, that is 4 pi r square plus 4 pi r square inside and outside, 8 pi r square T. Substituting the values, we have 18.84 into 10 raised to minus 4 joule. Find the amount of work done in blowing a soap bubble of surface tension 85 into 10 raised to minus 3 Newton per meter from 4 mm diameter to 6 mm diameter. So the initial radius of the bubble is 4 by 2, that is 2 mm, that is 2 into 10 raised to minus 3 meter. Final radius of the bubble is 6 by 2, that is 3 into 10 raised to minus 3 meter. So increase in surface area is 8 pi, change in radius square, that is 8 pi into 3 into 10 raised to minus 3 whole square minus 2 into, that is the initial radius, this is final radius minus initial radius, 2 into 10 raised to minus 3 whole square. So substituting the values and simplifying, it is 125.6 into 10 raised to minus 6. Therefore amount of work done is this increase in surface area into surface tension, that is 125.6 into 10 raised to 6 into 85 into 10 raised to minus 3 that gives 10.676 into 10 raised to minus 6 joule. A soap bubble is spherical in shape and has a diameter of 10 centimeter. If the surface tension of the surface separating soap solution and air is 40 into 10 raised to minus 3 Newton per meter, what is the excess pressure of air in the bubble over the atmospheric pressure? So we have radius 10 by 2, that is 5 centimeter, that is 5 into 10 raised to minus 2 meter. Surface tension 40 into 10 raised to minus 3 Newton per meter. Excess pressure is 40 by R. Substituting the values, we have 3.2 Newton per meter square. Now calculate the energy released when 8 droplets of water of radius 0.5 millimeter coils to form a single drop. Given surface tension of water is 0.072 Newton per meter. In this problem, we have 8 droplets of water of radius 0.5 millimeter. They combine to form a single drop. So we want to find the energy. So radius is 0.5 into 10 raised to minus 3 meter. Surface tension is 0.072 Newton per meter. So volume of one big drop, the volume will be same. So volume of one big drop is equal to 8 times volume of one droplet. That is 4 by 3 pi r cube. Let capital R be the radius of big drop and small r be the radius of droplet. Therefore 4 by 3 pi r cube is equal to 8 times 4 by 3 pi small r cube. From that, capital R is 2 times r. That is 2 times 0.5 into 10 raised to minus 3. That is 10 raised to minus 3 meter. Surface area of 8 droplets is equal to 8 times 4 pi r square. That's equal to 8 times 4 pi into r is 0.5 10 raised to minus 3 whole square. That gives 25.12 into 10 raised to minus 6 meter square. Surface area of one big drop is 4 pi r square. Only one drop, therefore 1 into 4 pi r square. That gives 12.56 into 10 raised to minus 6 meter square. Therefore decrease in surface area is 25.12 into 10 raised to minus 6 minus 12.56 into 10 raised to minus 6. That gives 12.56 into 10 raised to minus 6 meter square. The energy released is decrease in surface tension into decreased in surface area into surface tension. That is 12.56 into 10 raised to minus 6 into surface tension is 0.072. That gives 0.904 into 10 raised to minus 6 joule. This much energy is released when 8 droplets of water of radius 0.5 millimeter combine to form a single drop. Calculate the work done in spraying drop of mercury of radius 1 millimeter into a million drops of equal size. Surface tension of mercury is 430 into 10 raised to minus 3 Newton per meter. Here radius of big drop is 10 raised to 1 millimeter, that is 10 raised to minus 3 meter, and surface tension is 430 10 raised to minus 3 Newton per meter. So we have volume of one big drop is equal to 1 million, that is 10 raised to 6 times volume of one droplet. That is 4 by 3 pi r cube is equal to 10 raised to 6 times 4 by 3 pi small r cube. From that, r cube is capital R cube by 10 raised to 6, or r is equal to cube root r by 10 raised to 2, and r is 10 raised to minus 3 by 10 raised to minus 2. It is here 10 raised to minus 5 meter. That is the radius of one single droplet. Therefore, increase in surface area is 10 raised to 6 into 4 pi r square minus 4 pi capital R square. This is the surface area of 1 million droplets. That gives 4 pi into 10 raised to 6 into 10 raised to minus 5. R we have given as 10 raised to minus 5, 10 raised to minus whole square minus 10 raised to minus 3 whole square. Simplifying, it gives 4 pi into 99 into 10 raised to minus 6 meter square. Therefore, work done is equal to increase in surface area into surface tension gives 5.35 into 10 raised to minus 4 joule.